Hello, I'm Ramla bouzida. I'm a PhD student. I have honored to participate in this international conference organized by the University of Ouargla, Faculty of Mathematics and Matter Science. My subject is studies about the magnesium YP system. I use the first principle calculation of the thermodynamic for calculating the enthalpy of formation of compounds and try to optimize the diagram. The intermetallics in the MgYP system at 0 Kelvin investigate by the first principle calculations within density functional theory and the generalized gradient approximations. The thermodynamic data and the phase diagram of the magnesium ytterbium system have been critically assisted by means of calculation of phase diagram. Technique uses the Batna-Beam calculation code and the MG2YB investigate in his observed experimental structure. The enthalpies of formation of the compound was found by the ab initio density functional theory using the VASP code. The first principle calculations were performed in order to determine the thermodynamic properties of intermetallics compounds in the MgYP system. The calculations employed the projector augmented wave POW method and generalized gradient approximation using the parameterization of Perdreau et al. I have two tables. The first one presents the structure properties of magnesium ytterbium and the enthalpy of formation of the compound Mg2YB. And the second one presents the enthalpies of liquid phase and compound phase Mg2YB. This results from ab initio calculation and thermodynamic parameters optimized. This diagram obtained by the code Batna-Beam and Panda. I was compared between the experimental data of 1964 and my work. On the right side, we have the enthalpy of formation of compounds Mg2YB obtained by the code VASP with the red circle and the black line with the Calfad methods. A good agreement with the liquids line between the calculated values in this work and the experimental data has been obtained. Except the left side of the diagram, there is a small difference in